So here,
This call is now being recorded.
okay, so here you have your question paper from 2024 November, which is your final paper. So very soon you'll be writing your preliminary exams, which is your trial. So there you can see if you need improvement or if you're still good. So let's get to it. So we've got here this table and a crate here, which is 8.5 kg, which is stationary. That means it's not moving on a rough horizontal table and is connected to a mass hanger by means of a light inextensible string passing over a frictionless pulley, which is this one here. This is our string here. And then the mass pieces are added to the mass hanger and acceleration of the crate is measured. So right, this is an experiment. Okay, so what they're doing here is they add mass on this here, and then test for the acceleration. So they've repeated this different times or multiple times, right? So now what they want from us is define static friction. So this is stationary. Do you know what is static friction? Does everyone know what is static friction? Right? So if you check your exam guideline, I think they have definitions there. So this is the force, right? This is the force. What does this force do? Remember, this is static friction. So this is the force that opposes, right? It opposes the tendency. So let me write it here. The tendency. What is tendency? This is the keyword here, which is very important. So tendency, it means this force here, it opposes the box from wanting to move, right? So this opposes the tendency of motion of a stationary object, right? So static friction, you only have it when the object is stationary. The minute it starts moving, then that is your kinetic friction, right? Okay. So relative or parallel to the surface. To a surface. Stationary object. So what this means is you've got a box here. Let me just use this 8 kg box here. So you've got this box here, right? So this box is not moving because there is static friction. So static friction points opposite. So in this case, opposite can be anywhere because we don't know or we haven't figured out where is opposite. So let's say opposite is this way. So we have 5 kg, 8.5 kg. So this would be your Fs here. This Fs, then you've got your tension here, which comes from this rope here, right? So this, it balances out this tension here so that the object doesn't move at all. So how does this happen? Remember, we have F net equals to MA, right? So this F net equals to MA. This F net is determined by our static friction in this case and tension, right? So if this side is 0, then you have MA, so that means this thing is not going to move. So that is where your static friction comes from, right? Does everyone understand? Seems like someone is talking. Do you understand? Okay, guess it was a mistake. So now that we know static friction, remember these are the keywords here. Here, stationary object, the tendency. Here, also the parallel to the surface. So your friction is always going to be parallel to the surface. This is your surface. These two things are parallel to each other, right? So it's always going to be the case. So next thing, they want a free body diagram showing all the horizontal forces acting on the crate just before it starts moving. So that means we are still considering stationary, right? So since they said all horizontal, so normally how you would do your free body, you do this. This is your point. You would have your normal force here. You would have your Fg, which is your weight. Then you have this force here, which is your tension, like this. Then you would have your static friction, like this, right? You wouldn't be wrong. You still be correct, but in this case, they said they want all horizontal. So you can just put it as horizontal forces only. But don't stress too much about it, because even if you write it as this here, you still wouldn't be wrong. They just wouldn't mark you for this, right? They'll just mark these two, the horizontal that they are looking for, right? So that's how it works. So this is your Fs, this is your tension. They said they want only horizontal, right? Okay, this is your 2.2 here. Okay, so let's move on. Okay, what is this thing doing? Okay, so now they are saying we are in 2.3. So 2.3, they are saying calculate the coefficient of static friction. All right? The coefficient. So they don't want the static friction part. In this case, they want the coefficient. So we already have our free body. This is our free body here. I'll write it the same way that we always write it. We've got your normal force. You've got your Fg. Then you've got your static friction. Then you have your tension here, right? So how then would we calculate our force here, our static friction coefficient, right? So what we do here is we say first thing you do here, F net equals to ma, right? Acceleration, your mass, your net force or resultant force here. So how you do it then is we have Fs here. Remember, Fs is equals to the coefficient of Fs, which is static friction coefficient, this one that we are looking for. So that means here we are looking for this thing here. This is our unknown, right? We can calculate the normal force. We can also calculate this static friction, right? Okay, let's move. So we already know that F net equals to MA, right? So in this case here, you would have, let's say, assume that this is positive, then this direction is negative, right? So in this case, you would have your T, which is positive, plus minus Fs equals to MA, right? So then this side, remember, this is not moving. So it's going to be 0. So we can say T plus minus Fs is equals to 0. There's no acceleration, there's nothing. So in this case, you can even say acceleration is equals to 0 meters per second squared, right? So what this thing is saying to us is that, let me paste it here again. Paste. Okay. So we said T plus minus Fs equals to 0. If you transpose this part to the right side, you'd have T equals to Fs, right? But in this case, we have two unknowns for this 8 kg diagram. So that means we don't know what is what, right? Okay. But if, let's say, we are using the crate itself here, this crate, this one, this mass here. So you've seen that from this part, you can't get anything because we've got two unknowns, right? So that means you cannot use this. So we have to try this now. So a free body diagram of that part is for this part, the mass that is hanging here. So we can say we have this. Since it's hanging, it doesn't have a normal force. So this would be your tension. And then, but it does have weight. So this would be your Fg, right? So in this case, we can have Fg is equals to mg. This is your 9.8 meters per second squared. This is your mass here. But now, not anywhere in this statement we've been given what is the mass of this thing here. But if we can check from this here, we can see that here, because this is acceleration of the crate, which is this. Then here we have, okay, this is mass hanging, right? The mass, the hanging mass, which is this one. So here, this is at 0 here. This y part is 0. Then here, the mass is 4.2 kg. So since it's like this, what is telling you that since the acceleration is 0, so at, let me write it like this, when acceleration is 0 meters per second squared, the mass of these pieces here is 4.2 kg, right? This is what is telling you, this graph here. So therefore, we can get our Fg. So therefore, our Fg would be 4.2 times 9.8, which is this one here. So equals to, please punch the calculator and share the answer. Please share the answer. Okay, so seems like you don't have
41,
calculators. What's the answer?
41.16,
41.16 newtons. Right, thank you. So, even in this case, remember we have this here, which is our free body, but it's stationary. So since it's stationary, it's not moving, that means your T is equals to your Fg. So the T here is equals to Fg. So that means your T is equals to 4.116 newtons, right? Then we go back to this part here, right? So if we go back to that part, let's move with our thingy again. Don't need to copy it. Let me just try pasting. Okay. So since we said T is equals to Fs, and we know that T is equals to 41.16 newtons, right? So that means we have Fs equals to 41.16 newtons, right? Remember, now let's go back to the formula of Fs. Formula of Fs, we know that Fs is equals to mu s times the normal force, right? Because we are dealing also with this. Okay, so we have the Fs here, but we don't have this part here. We don't have this. We don't have this here. We don't have this also, right? So we're looking for these two. But we can get our normal force here, because our normal force is simply equals to the weight. Do you agree? Okay, so our normal force here equals to Fg of this crate here, which is your 8.5 kg. So what we're gonna do is say normal force equals to mg, which is equals to, what is m? 8.5 times 9.8. 9.8. So then our normal force would be this. What's the answer? I'm waiting. Okay. So this is what you'd have here. 83.3 newtons, right? So we have this, we have the F here. So what we can do is something like this. We can say Fs equals to mu s times normal force. Fs is this here, which is 4.116 equals to mu s, and then times 83.3. Simply divide both sides by the 83.3, 83.3. Then you would have your mu s here. What would be the answer?
0.94,
0.94.
94, 49, sorry.
0.49. It doesn't have any units, right? So this is your final answer here, right? So this is your final answer. So that is how you get the mu. Okay, let's move to another question. Paste the box here. Okay, so I need to remove this, paste it somewhere here. Okay, let's carry on. So now we are in 2.3.2. Okay, now they are asking us, calculate the magnitude of acceleration represented by y on the graph if the coefficient of friction between the crate and the table is 0.4. So now we have a new coefficient of kinetic friction, right? So let's start with it first. So here, let's do this. Fk equals to mu times n. This is mu k. Mu k is 0.4 times the normal force for this part here. We've done it is 83.3. So it's 83.3. Then you can have your Fk here, right? Because we're still speaking about this box, right? And this surface here, which is a rough surface. So you can get your Fk. What is our Fk? This is your Fk here. And then here we have, because they want us at y, the acceleration at y. And we know that the acceleration of this part is this for, no, not the acceleration, the mass instead. So the mass here, if we want y, the mass is of this part is going to be 7.4. Okay? So we have this mass here. We can get the weight and the other stuff that we want. Okay? So let's start now. Let's start with this box. We know that, let's use this one, F net equals to MA. So this is the A that we want, right? So F net, we know that we have the friction. We have the friction, and then we have also this, the tension here, right? So we've done it before. So we said tension is plus minus Fk in this case, because now we're starting to move. So it's going to be Fk. And then equals to Ma. We have this kinetic friction, so we can say minus 33.32 equals to, the mass is, don't mix it up. This mass is not for this box here, it's for this hanging. So you can say here 8.3 times acceleration. Okay. So now that means we can work on getting our acceleration. So to do this, let's say this is equation 1 here, because it has two unknowns. It has this, we don't know it, and this, we don't know it. Because whatever that we're doing before was for the static object, but now it's moving. So we can't entirely say this is the same as the previous tension that we calculated. Okay, so we can do it like this then. So let's say now, this is for the 8.5 kg box here, which is your crate. Then here, the hanging mass. So for the hanging mass, we also did the free body. So the free body, we had something like this. You had your tension here, and you had your FG. And this was equal because it was not moving. But now, when it's moving, then that means it's a different story, right? So that means we have to introduce our F net equals to MA again, right? So we have two forces. If let's say we take this as positive, which is the one going up, then the one going down is negative. So you would have your tension here plus minus Fg equals to MA, right? This is what you would have. Unless you flip it. So, but now what we have to consider here is that, so this is increasing and it goes. So remember, we took this side as our positive. This is here. Where is it? This is here. Then this is negative, right? So as this thing is getting pulled up, it's gonna move like this. So it's moving to the negative side. Okay? Do we get that? So if it's moving to the negative side, that means the tension here is gonna be negative because it's going. So remember, this side was going to the left, to the right, so it was positive. Now this one is gonna be going to the left, so it's gonna be negative here, right? So let's make this negative, then let's make this positive. So it would change our stuff here. Then this would be like so, Fg plus minus tension. Then not Fg, Mg, Fg. So here, the mass, we know it is 7.4 times 9.8, right? Plus minus T equals to, the mass again is 7.8 times 8, right? So let's punch in the calculator and see. It's going to be 7.4 times 9.8. Let's see what we have here. We're going to have 72.52 minus T equals to 7.88. We can make this our equation 2. Then we need to just come back and make this here the subject of the formula. So remember, we have this here. So we have T plus minus 33.32 equals to 8.38. So we make T the subject of the formula. We'd have 8.3A plus 33.332. This is what we would have, right? Then we have our equation 2 here. This is what 1. Updated 1, we'd have 72.5 72.52 minus T equals to 7.8A. So you can just take this and substitute it here, right? So you can come here and say 72.52 minus 8.3A plus 33.32. So I'm substituting here. So I'm putting this in a bracket so that we don't miss this sign here, right? So then equals to 7.8 A. So you would have something like this then. 72.52 minus 8.3 A minus 33.32 equals to 78.8. Right? Then group the like terms as we know it from our mathematics. So here you would have something like this here with this. Then you have this here with this. Okay. So that means we can have the 72.33, 72.52 minus 33.32. That means here we're going to have 39.2, then equals to, this is negative. If we take it this side, it's going to be positive. So it's going to be 7.8 plus 8.3. So that means we're going to have 16.1 A, right? Then you divide 16.1, 16.1. Goes away, have your A here as 39.2 divided by 16.1. So you're going to have your 2.43 meters per second squared. Okay, this is what we'd end up with here. Okay, do you understand? Okay, if everyone is quiet, and then I assume you understand. Let's move to 2.4. So here, the question is, so this 5 kg block is now placed inside the crate, and the experiment is repeated. How this does, that means here we are adding 5 kg here. How will this affect the maximum static frictional force now experienced by the crate? Chooses increase, decrease, or remain the same. Okay, so let's check this out. Remember, static is equal to mu times n, right? So what this thing is asking us, so we are talking about mass, but in this formula we don't have mass. But we know that n is equal to mg. So that means if we increase this mass here, we're actually increasing n, right? So if we increase n here, this is the n that we're increasing. What would happen to this maximum static friction? That means also it would increase. So let me make an example for you. So let's say the static coefficient that we had was 0.49, right? So this is Fs equals to 0.49 times n. We've done this before, but I'll repeat it. So we've increased this mass here. If we increase the mass, we increase the Newton, the normal force. And if the normal force is increased, in this case, if, let's say, let's start with normal force at 10. So 0.49 times 10. We're going to have something here, right? So if it's like this, 0.49 times 10, that is 4.9 newtons. But let's say we increase it to 20, right? So 0.49 times 20 now. So let's do this. Times 20, that means you have a 9.8 newtons. So you see it has increased. So that means if you increase this mass here, this static friction is going to increase. So what they want from you, the reasoning you should give them is that your static friction, which is max, is directly proportional to normal force. So that is to say, if you increase normal force, you are increasing the static friction, right? Or you can say max is directly proportional to the mass. Because here, if I increase this mass here, that means I'm also increasing the maximum static friction. So this is the proportionality. But let's say if we had something like, let me make an example. So let's say we have F net here equals to MA. All right. So this is M over M. Then you have A equals to F net. All right. So in this case, for the acceleration, if I increase this mass here, so it's more like you have one apple here, one apple. And then you have to distribute it among 5 people. So that means each person is going to get a smaller piece, right? But if this apple, I have it all to myself, I have one big piece. So that means I have one big acceleration. So the minute I increase the number of people, which is our mass here, the more I'm going to have less and less acceleration. So it's more like you're saying to me, my F net here, let me just say F net is equals to 1, right? And if F net is equals to 1, and I have to divide it by 10, then I would have a 0.1 acceleration here. But if I divide it by 2, so this is a less number. So if I divide it by 2, I would have a 0.5, which is way, way bigger. So that means here, in this case, in technical terms, your acceleration is inversely proportional. Inversely means there is a division here. So the more I increase this mass here, I'm going to have less acceleration, right? So this is what it's saying. So in case this also comes up, you should know what you're dealing with. Okay. Do you understand? Please give me a thumbs up if we understand the stuff.
Sir,
Yes.
can you please repeat it? I don't understand.
Okay. So here, let me repeat it again. So just remove this, divide the page here. Okay. So what I'm saying here is that, let me start from this again. You have your Fs here, it's equal to mu s times n, right? So in this case, I'm saying if you increase this, if you increase the normal force, that means I'm going to have more of static friction. So how this thing happens is you have this box here. If I have 5 kg, 5 kg, we remember that normal force is equal to mg in this case, right? So if I increase this mass here, this is the mass. If I increase this mass here, that means I will have a larger normal force, right? If I decrease, so I'd have a smaller one, right? So let me substitute this. Maybe it's gonna make sense. Then times mg, right? So you see, what happens is you've got multiplication here. if I increase, so it's more like, at first, let's say this is multiplying by 1. So it has something like this. But if I put 2 here, then this thing increases, right? But if I divide it, let's say I divide by 2, then it decreases. So what this thing is telling me is that this mass here, you increase the mass, that means I have more of this. It multiplies more. You have more to multiply with, right? Then if you decrease this mass here, then this thing would also decrease because it's highly dependent on this. It's one of the things it depends on. Okay? So this is what happens. So if you say, we can then say Fs max is directly proportional to mass. This means if you increase the mass, you increase Fs. If you decrease the mass, you decrease Fs. Or max is directly proportional to normal force. If you increase the normal force, you increase Fs. If you decrease it, you also decrease Fs, right? So this is what it's actually telling you. You can use the numbers like this here so that it makes sense to you. So you see here, we started with 10, normal force is 10. Then we increased from 10, we went to 20, right? So you see here, it was smaller. But the minute we increased the normal force, we went to 9.8, which is much bigger compared to 4.9. Okay? So this is what happens here. Are we good? Okay, we'll see it as we go with more examples. So let's start with this one here. This is from 2022, right? So from 2022, we've also gone through this. So let's say the crate P, this is a crate of mass 1.25 is connected to another crate Q, 2 kg, by a light intextable string. The two crates are placed on a horizontal rough surface. Remember, I did tell you that before. If you say rough surface, they are just telling you that we have friction there. We have friction. So now a constant force F of magnitude 7.5 acting in an angle theta to a horizontal is applied to crate Q. The crates accelerate at 0.1 meters per second squared to the right. So that means they are going this side. Okay. So crate P experiences a constant frictional force of 1.8 newtons. Crate Q experiences a constant frictional force of 2.2. So you see, this thing is supporting your rough surface. So because sometimes they're not going to give you the frictional forces. They might give you the constants or something, right? So you can state your Newton's second law here in words. It's not an issue. Let's start from 2.2. So draw a label-free body diagram for crate P. So this is crate P here. So crate P, we have crate P as our dot. It's on a flat surface. Since it's on a flat surface, we must have a normal force here. All right. And then we must have your FG here. Then we have a string. So by a string, we have tension. So that means this is a string, has tension. Then here, they've stated that there is a constant frictional force. So that means here, you're going to have your Fk here, right? Which is your frictional force. Okay? So let's start now with the exciting stuff. So you have now your 2.3.1. They want the tension in the spring, right? So since they want the tension in the spring, so here we're going to have F net equals to MA, right? So F net here in this case, so let's choose this direction as positive, right? So if this is positive, this is negative. Then we're going to have T plus minus Fk, because Fk is going to the negative side. Then you have MA, right? So which one are we considering first? So let's start with P. So P, this is body grade P. So P, what is the frictional force of P? Is 1.8 newtons, equals to the mass of P is 1.25. Then times A. This should be negative. Don't forget, right? So since here we've got two unknowns here, we have two unknowns because we can't just get, okay, we don't actually. We don't have two unknowns actually because there is somewhere where they told us about this thing here, right? So that means here you would have to substitute your acceleration, which is 0.1, right? And then your T is equals to 1.25 times 0.1, and then plus, because you take this to this other side, 1.8, right? T is equals to. So what would be the answer? Please punch in your calculator. Okay, 1.25 times 0.1 plus 1.8. You should have your 9, not 9, your 1.925 meters per second squared. But convert it to decimal places. So that would be T, not this here. 1.93 Newton. Okay, so this is the final answer here. Okay, do you see it? Do we understand? Cool. Thank you. So let's move. So now they want angle theta. We have not seen this one, but we should be happy because now this is going to test us. So we see if we understand the stuff, but it's better if it tests you at home before exam, because exam, you might not get what you want. So they want angle theta. So angle theta, we already know we can only get it if we are looking at this part here, right? So let's start. So 2.3.2, let's start with the free body diagram of Q. Create Q. So that means here I'm going to have this. I'm going to have my normal force, Fn. I'm going to have my Fg. Then I'm going to have my tension here. I have tension here. Then I'm going to have also my FK here, which is mentioned here, right? Don't forget, please. Sometimes if they just tell you that so that you don't forget, you can just put here so that you have your rough surface so that you don't forget, right? So then you'll know that this friction. Then I have my force here, which is this. So this is at an angle, F is equals to 7.5 newtons, right? So in this case, I can take this thing here and make it, because this is how you can draw, or let me just put one big stuff here. Let me just say or like this. So or you can have something like this, which is gonna be your Fn. This is your Fy. And then you're gonna have your T here. And then you have your Fk. And then you're gonna have your Fx. These are components. Remember, these are components. So how do we get these components here? So this is how we get our components. Right? So for these components here, you're gonna have your F, your Fy. Here you're gonna have your Fx. Then here you're gonna have your F. So let me do it here. You see, this is where the triangle is coming from. Then this is your theta. Then this is your right angle triangle. Right? Your 90 degrees. So if we want Fy, we are here. You simply look here. This is already known to us, which is 7.5 newtons. So we can use sine to get this Fy, right? So it's going to be Fy over F. Okay? So that means Fy is going to be F, because the cross multiply, right? Cross multiply. F sine theta. Okay? Do you see it? Okay. So then, let me just move with this. If we want now y, we want x here, fx. Fx, we're gonna use cos, right? Because cos theta equals to fx over f. You cross multiply here. You cross multiply. So that means you're gonna have your fx equals to f cos theta, right? So now, since, oh, I forgot to put the weight here, your Fg. So in this case, we have these forces here. These ones, the horizontal ones. Let's look at the horizontal forces, right? So this is going to the positive side. This is to the negative side, okay? So that means F net, let me write it again so that you see. That means F net equals to MA. So for me to get F net is equal to T. It's equal to Fx, because it's positive. Let's start with it. Fx here from the free body. So always draw your free body so that things become easy for you. Then plus minus Fk, which is my friction, plus minus T, which is my tension, equals to Ma. So from here, my things have become easy. So I can substitute and say F cos theta, this here, right? Plus minus Fk plus minus T equals to Ma. We have values for some, but we don't have values for this theta here. So we can get it. Let's see. So this here is 7.5, right? So we're gonna have 7.5 cos theta plus our FK is 2.2, which is this one here, 2.2 plus our tension is what is our tension? Our tension is, we calculated it here. This is our tension, 1.93. So we can come here and say 1.93, which is equals to what is the mass of this crate Q, which is 2 kg, and the acceleration is 0.1, right? So come here, we say 0.1. So now we have one unknown in this case here. This is the unknown that we have. All right. So we can, this is supposed to be negative. Please don't forget the negative. So let's start with the like terms. So here you're going to have your 7.5 cos theta equals to, take everything else to the other side because these are just a bunch of numbers here. So you can say 2.2 times 0.1 plus 2.2 plus 1.93. Then you should get something like 2 times 0.1 plus 2.2 plus 1.93. So this is going to be 4.33. Then 7.5 cos theta, right? Divide both sides. 7.5. 7.5 goes away. We have cos theta equals to, divide by 7.5. Then you have a 0.577, right? So we want theta. So since we want theta, we can say theta is equals to cos 0.577. What is the answer for our theta?
54.76.
So 54.76 degree. So this is your answer here. Okay, do we understand? Okay, coolies. Thank you. Let's move. So was this the last question? Because I had a bunch of questions here. So this was the last question, it seems. Okay. Should we carry on with these questions or what do we do? Because we are done with questions for Newton's law. Or do you have any question paper that you would like to look at? Any. Okay, let me look for this one question paper that I once took it through. I think it's from 2023. Let me just get it quickly so that we make sure that we understand everything. So this is November. Okay, let's see if we can get it. So then these ones we can do it next time we are together so that you don't get confused. Okay, we've done this before. just in case you were not here. So in this case, we had something like this. I did it during my lessons. Okay, we have something like this. So instead of the boxes that you were seeing, you now have something similar but on an inclined plane. So you have these two on an inclined plane, right? So here you would have this box here, box one. Then you have this other box here, box two, box two. Then our force is flat like this, which is force F. This is your 9 kg. This is block B, this is block A, 4 kg, right? So this is on a rough surface, okay? So let's do this. First of all, you would have to define your Newton's laws and all, right? So now there's acceleration here, which is 2 meters per second squared. Then box A has friction of 5.88 newtons. Then box B has 13.23 newtons. Okay. So for me to see that you understand, you need to guide me here. So the first thing they want the free body diagram for box A. So let's talk. How do I draw a free body diagram? Let's start for box A. Okay, let me give you a clue so that you can see. I'm just gonna put something like this. Oh, and I'm gonna help you put the dot here again. Yeah, please, let's define the forces.
Gravity.
Gravity. Okay, so you're gonna have your FG here, which is your weight. Another person, please.
We have
Normal.
tension.
We have tension.
Yes.
So tension would go something up like this. This is your tension. Which other one?
Normal force.
Then you would have your normal force. Please remember, normal force is always perpendicular to the surface. Always perpendicular to the surface. Please don't forget. Another force, please.
In
Which one?
frictional force.
Then you would have your frictional force here. Right? So now you've got your free body. So frictional force I've already mentioned here. So everyone should be able to see that there's frictional force. Even here, this one. If you don't see, please ask now how to see it or anything. Just ask so that you don't leave without understanding things. Okay? Then I said to you, let's remember, we have here components. Here, the components of weight. We have the components of weight. Components of weight is F, G, parallel, and FG, perpendicular. This is perpendicular. And in this case, in an incline like this, your normal force, if you have a normal force here, you are used to your normal force being equals to mg. But in this case, it's not, right? It's not. Okay, before I carry on with this, let me show you something else. that we've also gone through so that if you are not here, you can see. You have a box here, right? So let me just I'm gonna take this box, the 9 kg box, but I'm gonna put it on a flat surface instead of the incline, right? So 9 kg. But now in this case, let's say the force was like this. This force was like this, and this is 100 newtons for this force. How would you calculate your normal force in this case? Let's just put this 35 here. Right? So in this case, still your normal force is not equal to mg. The minute you see this angle here and you see an incline here, it's no longer equals to mg. Only on a flat surface is going to be on a flat surface, and when there's this force here is not at an angle, then it's going to be equal to mg. So in this case, as said before, you would have, let me put it in a form of a free body, you would have your normal force here. Then you would have this force here, which is 100 newtons, but it's at an angle. Then you would have your Fg here. Then you'd have your friction, right? Your Fk. So now remember, this here has components. This has components. It has the y component here, Fy, and the x component, which is Fx, right? So since we want normal force, you would have to only use the y forces, not the x forces, which means the vertical forces. So since Fy and N are going in the same direction, let's assume it's positive. So we can say N plus Fy. Then these two should be equals to Fg. The reason we are saying it's equals to Fg is because we are not having movements going up or going down. This is stationary, right? So it's always going to be like this. But in a case whereby now this thing is moving like this, then it changes things, right? It changes. So this is how you would calculate your normal force. So normal force is equals to Fg minus Fy, like this. Then this is gonna be your normal force. So how you calculate your component is what I just showed you previously here. Your Fy is gonna be F sine theta. So that means Fy is equals to F sine theta. For this case that I'm showing you here. So now let's go back to this question, right? It's gonna be a mess. It's fine. I'll redraw. So now we have our free body here. Let me redraw it. Fn. Then you have your Fg. You have your tension. You have your Fk, which is your friction. Then let's introduce this. You're gonna have your Fg perpendicular, your Fg parallel, right? This is how we are going to do it. So in this case, if they want, let's say we're supposed to calculate something. So your F net here, your resultant, let's say your resultant force. So resultant force, it means where the force that I will get if I add this plus this other one. Please don't forget this. It's very easy to forget. So it's going this direction. It's going to be positive, right? So this is going to be positive. So that means our tension is going to be positive. Then plus we have Fk, which is going to the negative side, minus Fk. plus minus FG parallel. So if you have an incline, don't forget these forces here. Okay, please don't. So this would be your resultant force, which is your F net. All right? So we know that. So now let's calculate the components. Let's put theta here and calculate the components. Right? So with the components here, this is opposite, we have this. So we'd have F, we have sine theta equals to FG parallel over FG. Okay. So then we'd have your FG parallel equals to FG sine theta. Then your FG perpendicular is equals to FG cos theta. Remember. So in this case, since I said to you, I said your Fn is no longer equals to your Fg. So that means your Fn is now equals to Fg perpendicular. That means Fn is equals to Fg cos theta. Okay. Please remember this. Don't forget. Don't forget. Then you can calculate whatever they want from you. So in this case, they didn't give us the F. They didn't give us the F. They gave us most of the stuff that we needed. So starting from this one here, we can say T plus, this is the first box, which is 4 kg. We're going to have 5.88 as our friction, minus 5.88. Then plus, this is our minus FG. This is parallel. Sine theta equals to MA, right? Equals to MA. So we can say T plus minus 5.88 plus minus FG is equals to mg. G is 9.8. So this is a 4 kg, which is m times 9.8. Then sine, our sine here, the angle was 35, sine 35, right? Then equals to m, still 4. The acceleration is 2. So here we can just say, let's write it here. So it's going to be 4 times 2. All right, so we can get the tension here. Let's make sure I didn't miss any forces. If I miss the force, you should tell me. So now we have something like this. You can say 4 times 2 plus 5.88 plus 4 times 9 and sine 35, right? Then plus this part here, don't forget it. This one here, plus 8. Oh no, I already put it here, so we don't need. Okay, you can put it in your calculator and see the answer we get. What's the answer? Anyone?
That is 6,36.
0.36 newtons. Thank you. So you see, you've got this. So now that we have this, it doesn't give us the force because the force is in this part of our question. So that means we need to consider block B, right? So let's consider block B. Again, I'm gonna look at block B. Then you will help me determine the forces. Oh, I left this one. I'll determine one force here for you. Force, this one here. Then please help me with the other forces. This is the diagram. Anyone? Give me one force that you see from block B.
Friction.
Okay, I have friction here. Then this is gonna be Fk. Then I'm gonna have another one here, which is gonna be which one?
Tension.
Tension. Tension, yes. And then after tension, I'm going to have at least normal force, right? Then I will have Fg. Okay. But now, remember, I just told you that we also have components here. Fg perpendicular, Fg parallel. Okay. So in this case, we can say F net equals to MA. The size, the weight is 9 kg, the steadying point. Okay. So these are going down. So that means we're going to have F as positive plus minus Fk plus minus T plus, don't forget this, minus Fg parallel equals to MA, right? So we're going to have F plus minus 13.23 plus minus 36.36 plus now this one here. We have the component here, Fg sine theta. So we can say minus Fg is mass, which is 9 kg, times 9.8 sine 35, okay, equals to 9 kg times 2. Then we can simply get our force F here, because these are just numbers. So you can just punch these numbers in your calculator, you transpose to the other side, then you get your answer, right? So as we have seen before, that sometimes they don't just want straightforward things. Sometimes they're gonna want the angle. Sometimes they're gonna, okay, let me do this. So let's say now you have your force here, the force which you can calculate later on. So in this case, for block B, they can say to you, what is, or let me not use what, calculate the coefficient of kinetic friction of block B. Okay, so that means you're gonna have your Fk equals to mu Okay, N, right? So in this case, your N is equal to this, right? So you can say you have your FK as your 13.23 equals to mu K. Then your normal force, remember, don't say normal force is equal to mg in this case. It's going to be your normal force equals to Fg perpendicular like this, right? And Fg perpendicular to 3 equals to mu K. Fg perpendicular mg sine, not sine, cos theta. Okay? Then you can just simply substitute your stuff here. This is gonna be the 9 kg block times 9.8 cos 35, right? Then you can simply divide both sides by the number that you get there. So it's gonna be 9 times 9.8 times cos 35, which is gonna be 72.249. 72.249 goes away, then your mu K is gonna be 18.2, 72.249. Then you're gonna have your 0.18, 0.183. Doesn't have any units. Okay, so this is how things look. So then next time we're gonna carry on with our questions for the work, energy, and power. Then from work, energy, and power, we can move into another chapter. Okay, I think that's it, guys, for this meeting. Any questions?